annual ski resort auction. Today we have 3 resorts in sale. They're all fully equipped with the same functionalities for you to monopolize and earn revenue on. However, the first resort I highly recommend because it's at a 50% discount. It's going to sell out really quickly.
A few moments later.
Hey, Miss Ng, why are you not thinking about this offer? It's so great.
Shh. Let me cook.
I'm not sure I trust her. What if these plans don't work well for my ski resort?
So here, Ms. Chang has given me 3 slopes representing each ski slope. However, I have a feeling this won't work out in my ski resort, and I will find out why. So let me use matrix form to find out what this will look like when they all intersect. So to put this in matrix form, I will take the coefficient of each variable and then write it as so, and then with a line here, write the answer, and I'll repeat that with the remaining 2 planes. Now with this matrix form, if I can use row transformations to get this position to be 0 and these 2 to be 0, then I'll be able to easily find what x, y, and z are when they intersect. So first, to get this to be 0, I will take I will times row 2 by 2 and then minus by row 1, which will make these 2 cancel out. So with that, we have, so first times 2, so it would be, I'm just gonna write that small here, so to help my calculations, 2, 10, negative 10, negative 12. And then this row minus this one, right? So 0, 9, negative 9, negative 15. And doing something similar with the third row, I will minus 3 times of row 2 from it. So as you can see from here, it will become 3 minus 3, and so on. And so that gives 0, negative 10, 10, 11. And then, okay, I'm going to repeat this type of procedure by having 10 of row 2, plus 9 of row 3, which gives you can pause the video yourself if you want to manually do these calculations. Okay, so looking at the bottom row, we can see that this row means that 0 of x plus 0 of y plus 0 of z equals to negative 51. However, this is known to be invalid because if everything is zeroed out, then it can't equal to an integer or a real positive number. So this means that there are no solutions for resort number 1. What does that mean? It can only mean one thing, which is that the planes are parallel to each other. Okay, now let's think about what this would be like for my ski slope. It doesn't matter if they're all facing this way, they're all like this, okay, we just know that they're parallel in some way. And in all these situations, well, this one, our poor visitors will never be able to slide anywhere. For these, they'll be tumbling down endlessly, and same for this. So it's evident that a resort where there are no solutions and all lines are parallel does not work. Hence, I almost got scammed into buying this resort. Okay, so resort 1 has been debunked for being all parallel slopes. Now, however, resort 2 is still cheaper, so I bet there's something suspicious about this. So, do you remember how you can transform this into matrix form? Okay, take the coefficients. Take the coefficients.
Yes, I do, Captain.
Thanks, Ms. Chang. Speed this part up so no one can actually hear us talking. So this is how it is when expressed in matrix form. And once again, just a personal method I use is I always try to zero row 2 out first. Zero the first position of row 2 out. And so I can achieve that here by having 2 times row 2 minus row 1, which gives... Now I'm also going to zero out the first position of row 3, and that can be achieved by having row 3 minus 3 times row 1. And then, as you might have noticed, as I did for my first resort, I get the second position to be 0 by multiplying row 2 and row 8 to have a common factor, and then minusing them so they're 0. So basically 7 row 3 plus 8 row 2 here. Okay, great. So here, in our last row, we finally have something. We can see that we have negative 5 z equals to -10, which means that z is 2. And now now that we have an actual, like a constant value for z, we can plug that into the second row, where we have -7y plus 9z is -17. So plugging z equals 2 into here, we will get that -7y plus 18 is -17. And then finally, we have that y is 5. And then lastly, plugging these two values into row 1, we'll have that 2x plus 3 times 5 minus 2 is 7, and that x equals to -3. So this means that resort 2 gives you one unique point of intersection. So to visualize that, it means that the planes are something like this. Yeah, one unique point of intersection. However, that is also an issue for my ski resort. Imagine this, all the slopes meeting at one point. That means all the skiers will be crashing at the same point. This does not give them enough time to slow down after they come down. So no, I can't have this. What I am looking for is a resort with a unique kind of intersection that gives them a landing area.
A little longer than a few minutes later.
Okay, fine, I admit that resort 1 and 2 are faulty, but I swear I'm gonna justify the 100K price tag of resort 3. So to solve for a line of intersection for these planes, you need to try and eliminate these variables so you can get some kind of vector equation out of it. The first thing you can do is to transform the first equation, so when you add it to the other equation, you can eliminate some variables. Okay, so I'm gonna transform. I'm gonna make a fourth plane, and the way I'm gonna do it is by multiplying plane 1 by -1, and then adding plane 2 to it. So basically, when you multiply -1 to plane 1, you get -x minus y minus 5z equals to 0, and then you add the second plane, which is x plus y minus 10z equals 0. So what you get, you eliminate x and y, but then you get -15z. So from this is very convenient because now you know that z is equal to 0 because that is the only valid value for this equation. Okay, now that we know that z is 0, we also want to know some kind of representations of x and y. So I'm gonna make a fifth plane. This time I'll also multiply plane 1 by some kind of multiple, so when you add it to the third plane, you can get some representation of x and y. So because this is 5z and this is z, to eliminate z, you need to multiply the whole equation by 1/5, so you can get this to just plus z, and when you add these together, you'll eliminate z and get some relationship between x and y. So if I write it out, it's like -1/5 times the whole equation of plane 1 plus plane 3. You get negative x y minus z equals to 0 plus x plus y plus z equals to 0. Now you can see that you can eliminate z, and then from this you'll get 4/5 of x plus 4/5 of y equals to 0. So, and then you can divide or multiply the whole equation by 5/4, and you get x plus y equals to 0. So the relationship between x and y is just y equals to -x. So the information we got is these two, and this means that if you were, okay, we know for definite that z equals 0, but then from this you can know that y can be represented by any kind of parameter. So now it can be just any variable. I'll just use t. I forgot what this is called. I called the wavelength, and I know it's not. It's not wavelength, bro. Use lambda. So we can write lambda equals to y, and with this relationship established, with this lambda equals to -x, so x equals to -lambda. Okay, and so now we can write out all this, and because z equals to 0, I'll just write it here. So if you write it out in vector form, you can write as y equals to z plus lambda x equals to 0 plus 1 lambda plus negative 1 lambda, and x equals like z equals to 0 plus 0 lambda. So if we write it on vector format, 0, 0, 0 plus x negative 1, y is just 1, z is 0, like this. This is the final answer of the line of intersection.
Oh, I get it. Okay, so even though you did scam me with the first two resorts, because the first one was parallel and the second had a unique point of intersection, both of which don't really work as ski resorts, you have proved to me that the third resort has a unique line of intersection. Okay, fine. I guess I will buy this on the then.
Hey!